Right, so we'll look at one example of normal distribution, and this is example 27 in the book, page 367, where you have the length of fish, the length of trout in a fish farm, normally distributed with a mean of 39 centimeters and a standard deviation of 6.1 centimeters. So first task here is find the probability that a trout caught in fish farm is less than 35 centimeters long. And well, the advantage here of having a computer is that we can model and graph this much easier. But let's just set up the expression for a normal distribution. So we have the length of trout. So our random variable is L, which is distributed normally with the parameters. See, the mean was 39 and the standard deviation was 6.1. And since the variance is the second parameter, we square the standard deviation. So variance is standard deviation squared. So if we wanted to model this in GeoGebra, we can use the probability calculator tool. We can see, just move the window a little bit. We can ask the program here to set up a normal distribution with the parameters 39 and standard deviation 6.1. And this is what the curve would look like then. So for a standard deviation, the curve is always symmetrically aligned around the mean. And you can see the mean here, 39 centimeters. And most of the data is clustered around the mean. The first question here is find the probability that a trout caught in the fish farm is less than 35 centimeters long. The way we could set it up here in GeoGebra is, we can just move the window a little bit. We can say that okay, we're starting with a the right side of the curve goes from 0 and up or beyond, and it should be less than or equal to 35 centimeters, like that. So now we have, you see the blue coloring. This is the part of the curve that is under 35 centimeters. And we get the probability or the percentage right here. So it's 0.256 or 25.6%. We can copy that into our Word document. This is, okay, we write that as the probability that S is smaller than or equal to 35 equals 0.256.